Have you ever seen a poll in the news and just thought, wait a second, how can they possibly know what an entire country thinks just by asking 1,000 people? I mean, it seems completely impossible, right? Well, it's not magic. It's actually some really powerful statistical thinking. So let's dive in and uncover the secret of how a small, carefully chosen group can literally speak for millions.
You see it all the time, don't you? Political polls trying to predict who's going to win an election, big companies trying to figure out which new gadget to launch, or researchers announcing some huge medical breakthrough. Turns out, they all rely on the exact same fundamental principle that we're about to unpack.
So yeah, this is the central mystery we're tackling today. How can a tiny, tiny fraction of people really represent the whole? It feels like a trick. It feels like it shouldn't work, but I promise you, by the end of this, you'll not only get the logic behind it, you'll see why it's one of the most powerful tools we have for understanding our world.
Okay, so the answer to our big puzzle, the whole key to this thing, boils down to one powerful concept: sampling. See, instead of trying to talk to every single person, which would be incredibly expensive and take forever, researchers talk to a carefully chosen few.
The whole goal here is to create a miniature version of the entire population that's still really accurate. Think of it like a perfectly detailed scale model of a building. It's so much more efficient, right? It saves tons of time, money, and resources, which lets researchers really focus on getting high-quality info from that smaller group.
All right, now this is probably the most important part of the whole thing. Not all samples are created equal, not even close. The method you use to pick people is everything. It's the difference between finding something real and getting a totally misleading result. And that brings us to a huge fork in the road. So you've got two main paths. On one side, you have non-probability sampling. This is the easy way out, interviewing the first people you bump into on the street. It's convenient for sure, but it's almost always biased and unreliable. But on the other, more powerful path, you have probability sampling. And here, chance is king. Every single person in the whole population has a known random shot at being picked. That, my friends, is the secret sauce for creating a sample you can actually trust. Okay, so if random chance is the key, how do researchers actually do it? Well, they have a whole toolkit of different methods, each designed to make sure the selection process is totally fair. Let's open up that toolkit and take a look at the most common ones. The purest form, the gold standard, is called simple random sampling. Honestly, just think of it like putting every single person's name into a giant hat, shaking it up, and drawing out your sample. It's that simple. Every individual has the exact same chance of being picked. You can't get much fairer or less biased than that.
Next up, we have something called systematic sampling. Now, this method is a little more structured, but it still has randomness baked right in. Imagine you've got a long list of everyone in the population. You randomly pick a starting point near the top, and then you just select every, say, 10th person from that point on. Here, let me show you what I mean.
This visual makes it super clear. Look at this list. Let's say our magic number, our interval, is 3. We might randomly start at the third person. Boom, they're selected. From there, we just count down 3 more to grab the 6th person, and 3 more to get the 9th. It's a really simple and efficient way to make sure your sample is spread out evenly across the entire list.
Okay, let's break these two down, because people get them mixed up all the time, but the difference is so important. On the left, you've got stratified sampling. First, you slice up your population into different groups, or strata, maybe by age group or location. Then, you take a random sample from each and every one of those groups. The best analogy is a fruit salad. You're making sure you get a little scoop of every single fruit. Now, cluster sampling on the right is different. You still make groups or clusters, but instead of sampling from all of them, you randomly select just a few of the whole clusters, and then you survey everybody inside those chosen few. Think of it like picking a few random tables at a wedding and interviewing every single person sitting at just those tables. So, we've used one of our cool tools to pick a random sample. But how does the math actually work? How can the average of that small group possibly tell us anything about the whole population? This, right here, is where the statistical magic happens. Let's pull back the curtain and see the principle that makes it all click into place. To really see this in action, we're going to use a super simple example. Just imagine our entire country is made up of only these 4 people you see right here, with these 4 values. Pretty simple, right? Okay, so first things first, let's figure out the true average for this entire tiny population.
The true population average, or mean, is 25. That is our target number. That's the truth we're trying to find with our samples. So burn that number into your brain. 25.
And now for the big experiment. What if we didn't know the true answer was 25? Let's pretend we're in the dark. So instead, we're going to take lots and lots of small random samples of just 2 people from our tiny population. We'll calculate the average for each of those little samples and just see what happens.
And here it is. This chart is the big reveal, the aha moment. Look at what happened. Yeah, sure, some of our individual samples were wrong. Some of them gave us an average of 15, others gave us 35. But look where they all start to pile up. The most common result, that tallest bar, smack dab in the middle, is centered exactly on 25. That's our true population average. Over the long run, the samples that were too low and the samples that were too high just cancel each other out.
And what we just saw demonstrates a fundamental, beautiful law of statistics. While any one sample you take might be off the mark, the average of all the possible samples will land exactly on the true population average. This is the mathematical guarantee that allows a small, random group to accurately speak for the whole.
Now, this isn't just some cool classroom thought experiment. This principle is the absolute bedrock of how we learn about society, about our health, about the economy, pretty much everything. So let's bring it back to the real world.
Seriously, this concept is everywhere. Every time you see a political poll, that's this principle at work. When scientists say a new drug is effective based on a clinical trial, this is the logic that gives them confidence. From a company deciding if people will buy a new soda to a factory making sure its products work, it's all powered by this one amazing idea.
So I'll leave you with this. Now that you're in on the secret, now that you understand the incredible power of random sampling, the next time you see a poll or a study in the news, what's the first question that should pop into your head? It's not how many people do they ask. The smart question is, how did you choose them? Because as we've just seen, the method is everything.